Hello, everyone, and welcome to the audience choice session. We have five 15-minute talks for you today on topics that you, as the conference attendees, have voted to be of most interest to you. And with that, I'd like to introduce our first speaker, Dave Linder, who is a software architect here at Maplesoft. He will start us off with a talk on transforming mathematical expressions. Welcome, Dave.
Hi, everyone. There are two basic kinds of manipulating that people can have in mind. One is mathematical, and then the other is structural. I'm going to focus mostly on the structural stuff because it's probably less obvious to people coming into Maple. People know how to do mathematical stuff, and they know what to expect and what to look for. But for structure, basically, Maple expressions are stored as structures which have operands, and the operands can be queried, and they can be queried by location. But some expressions can also be queried by type. First, I'm just going to go through some of the operand by location stuff. So if we have an expression like arctan xy, the zeroth operand of this is arctan. The operands where it says all of them doesn't give the zeroth one, but it gives the other two. It's a function call, so the operands are the arguments of the function call. And the second operand is just the y. And I think that makes quite a lot of sense. And we can access them by position. For example, we can do it in a nested way. So the first operand of this x squared plus y squared equals 1, the first operand is the left-hand side. The second operand of that is then the y squared. So I can either take the second of the first, or I can take the left-hand side of the first. In both cases, I get y squared. So that's a really important and fundamental mechanism for dealing with Maple expressions. However, we'll get into a little bit later why some of it's a little tricky or dangerous for mathematical expressions, particularly because things can be sorted so that the y term appears before the x term, in which case, if all your code is specifically by location or position, you could all of a sudden have your code break if you rerun it or if you change the variable names and so on and so forth. So in this expression, the second operand is the cos x. I can actually now replace, using the subsop command, I could replace the whole cos x, or I could replace the first operand of the second operand. So the second operand is the cos x. The first operand of that is the x. So I'm going to replace that x and only that x with the s. So this is much more targeted than like subs x equals s, which would knock the other x off as well. I've targeted specifically to the second operand. But again, these terms could be reordered, so operating by position is sometimes a little dodgy. Instead, often people prefer to deal and manipulate sub-expressions by their type. Now, Maple's type system is pretty much one of the most basic and fundamental things for how to code and program in Maple. The type system is very, very sophisticated. It's been around for a long time, and it has both simple types as well as arbitrarily complicated structured types, which you can build yourself. And there are a lot of commands that support the type system, both for querying inside an expression and for replacing things. One of the most important functions in Maple, in my opinion, is the indents command. The indents of that expression that we had before are all the addends, basically, of the expression. The expression is of type plus, and all of the addends are its indents. But I can target and ask specifically for indents of a particular type. I could ask for all of them of type name. I may be in a situation where I want all the variables, so I don't want constant names. So I can ask for the indents which are of type name, but which aren't constant. Now we're getting somewhere. I could also ask for specific functions. I could ask for all of the indents which are a function of cos. I get those two. I could now ask for functions of cos, but where the argument is of type exactly x. I could also look at expressions which have dummy variables. By a dummy variable, I mean one which isn't has a meaning for the expression. For example, this expression, this summation, the n is the summation index variable, and the expression doesn't depend on n. It depends on k, it depends on x, it depends on f, but it doesn't depend on n. So now, if I ask for all the names that are not constant, I'm going to get that n in there. So I can actually exclude that. I'm going to exclude it by using a very, very powerful type, which is type satisfies. Type satisfies basically allows you to put inside it any arbitrary predicate you want, something that will return true and false when it examines whether something is acceptable or not. In this case, it's only going to accept the name if the expression itself depends on that mathematically. And this summation depends on x, depends on k, but it doesn't depend on n, the dummy variable. So I only get the k and the x. So you can really target the subexpressions by type, and the type system has a huge and extensive help section. You can learn a lot just by reading through all the different types, because they come up in day-to-day quite a lot. Another nice thing about the index command is that there are corresponding commands to replace subexpressions that match the type. And those subindex and eval index commands, they take almost exactly the same syntax as index, but they have a third argument which says what to do with that index when you find it. So it finds all the indents of a particular type, and then it does an action on them. So here I'm finding all the indents of this expression, which are of type a function of cos. And now I'm going to evaluate them. And I'm going to evaluate them with x being equal to 2, but just in those cos calls. And what happens here is that when I put in a 2 in here, I'm going to get cos of 2 pi. And I'm going to get a 1 out of that. So that's my replacement. I could also use subs instead of eval. Now this is an unevaluated result. If I was to evaluate this, the cos of 2 pi would immediately become 1. The reason it's sometimes nice not to evaluate things when you're doing substitutions is you may want to do multiple nested substitutions, and you might not want everything to evaluate in the first instance. You might want to just do a particular substitution and then come back to that, or nest it with another type of substitution as a follow-up. And if you get evaluation and it disappears, you can't do that. In the plotting session earlier today, I made some examples where I talked about manipulating plot structures. Plot structures are actually just nested function calls with a lot of data and other stuff in them. As Maple function calls, as a data structure, you can operate on them with exactly the same kind of commands that you could operate on other kinds of expressions. So here I'm making a contour plot. It used to be a few releases ago that this kind of contour plot, the contour lines themselves would be black. And here they've been cleverly replaced. And so instead of the contour lines being black, they're actually this matching colors to the filled regions. It's actually nice to have those curves there, because otherwise the edges of the curved regions might look a little jagged. I'm going to now replace all of the curves in this thing. So there's polygons for the filled areas, and then there's curves, which I can't see because they match the colors. But I'm going to replace all the curves with curves that are black. And now I can get a function, a result that looks the way it used to look. Anyway, you can do arbitrarily interesting and complicated type of operations on plot structures. But again, it requires knowing what types mean and knowing what some of the commands are for replacement. Of course, the most popular and common type of replacement and substitution that people do is using the command subs and eval. The difference between them is that the subs command doesn't evaluate, as we mentioned before, but an evaluation subsequently will cause the cos of 3 pi to become -1. The eval command both substitutes and evaluates. So you get the -1 directly. Another very, very common request is to replace sub-expressions that exist mathematically, but not literally. So in this expression, some people are going to say, well, x times z, it exists here. It exists in this term, but they'll say mathematically it's also in this product and in this product. And I want to replace all instances of x times z by something else. And I want to hit these two as well as this one. If I just replace x times z equals 7, it'll just hit the one that is literally the same structurally. The algsubs command will do a substitution, but it's smart. It will do an algebraic substitution and it'll look for sub-expressions which are products that also contain the multiplicand x and z. So here, this term has also been replaced by 7 for the x times z. Now, why didn't this one work? X times z. The reason for that is that it's a Mapleism. This is 1 over. It's x times z to the -1, or 1 over, it's x to the -1 times z to the -1. And that doesn't match this in the way that algsub expects. So what am I going to do? I could do a double algsubs. I could replace the x times z and the 1 over x times z, and then I'll get the result I'm looking for. That's somewhat awkward. If you have 3 things in your products, or a whole bunch of different expressions that you want both denominators and numerators to be handled, this can get a little tiresome. So an alternative is to use what's called simplify with side relations, which also has a help page. This basically does a simplification where this result is used mathematically in a sort of very natural way. It also does some simplification though. So sometimes this is what you want, sometimes not. Another way to manipulate Maple expressions, of course, are the stock commands that I think most people will be familiar with: taking the right-hand side of an equation, taking the denominator of the right-hand side. Now here I'm using a syntax where I've got a nested call. I'm using a syntax of functional operators. You can do all kinds of things with this kind of syntax. You can even add 2 operators. For example, you could go sine plus cos of x, and the result will be sine of x plus cos of x. So there's a certain amount of arithmetic and a certain amount of nesting that you can do on expressions. Again, this is a powerful syntax. Functional operators have a large part to play in Maple usage. Finally, there's the convert command. I can convert expressions, but I can also convert things which, if I was to evaluate them, would immediately turn back to the thing. So this is an unevaluated function call. And the reason it returns unevaluated is that it allows the system to operate in a composed way. I can convert to cos and then to exp, and it wouldn't get the result as if I had just converted directly to exp. However, it is equal to the original expression.
2 minutes.
And the last type of manipulation that is very common and often asked for is the ability to sort subterms in a sum or a product. I'll just deal with the sum here. So the first time in a session that a sum is created is the form that it's going to take place, it's going to take wherever it appears, even in any other expression. If I was to now write an expression with y minus x, it would turn into minus x plus y. And some people have a strong preference for one form or another. Well, it turns out that the sort command isn't just for lists and sets and things. It can actually sort polynomial expressions by a lexicographic ordering that you supply. If I specify the lexicographic ordering yx, I can actually turn this into the form that I desire. But again, the thing to note is that this is a global effect. There's only one instance of y minus x or minus x plus y stored in Maple's system. And so any other expression that contains minus x plus y will now appear in this form because it's a unique form stored in memory.